parabola, where it is on the first quadrant, and we do not have formula in finding the area for this irregular shaped figure. Okay? So, for us to determine the area of this region R, like I said, it as region R, so we have to divide the regular shaped figure into n rectangles. Okay? But still, we will have some parts that will not be included. Okay? And this is where we have now the application of integral applies. Okay? So we have now, if we're going to have the region bounded from left and right side, where we have x equals a and then x equals b. So the formula or the symbol notation that we have is the integral of f of x dx, where f of x stands for the region, and that is from A to B. Okay, that's from A to B. And there are two methods of solving the area of this region using the rectangular method. And we have the rectangular methods have two parts. We have the horizontal strip and the vertical strip. Okay, so strip is a rectangle. Okay. So with this representation of one rectangle, horizontal or vertical strip, we can define the area of an irregular shaped figure. Okay, having find the area of the region bounded by the curves x equals y squared and line x equals 3. So let us now have this sketch. So 0, 0, then it opens to the right. Okay. Then we have another curve that is line x equals 3. That will be part of the region. So where is x equals 3? So you count the units from the origin. And then this is now your x equals 3. And identifying now the region, we have the common part of the two curves, and this is the shaded part here. So this is the region that we're going to find the area. Okay? So let us now define the area using the strip, which is horizontal strip. Okay. So by horizontal strip, we have now. So you draw a rectangle from here, from the graph. So that is a horizontal rectangle. Okay. So this will be the one representative of the many rectangles that can be formed from this region. Okay. So using now this horizontal strip, so we have the formula of rectangle last time as length times width. Okay. So what is then the length here? The length will be represented by this side here, and the length is, if it is a horizontal strip, we say that the distance between these 2 points is abscissa right minus abscissa left. Okay? And what is that abscissa right? From the given figure, we say that abscissa right is the line x equals 3, and we have the abscissa left, which is the graph of the given curve y squared. Okay? Then what about its limits now? For the width, we have this now as this is the width. Since it is a horizontal strip, this can be represented by the variable of integration dy. Okay? And then, what about its limits? For its limits, let us identify the 2 points of intersection of the line x equals 3 from the curve x equals y squared. So how do we determine the point of intersection? For the point of intersection, we will just substitute now the line or the value of x equals 3 in the given equation of the parabola x equals y squared. So that we have here now. So when x equals 3, so that y squared equals 3. So what is that y? Plus and minus square root. Okay? So we have this as the upper and lower limit respectively. Because at x equals 3, we have the y value 1 positive square root 3, the other one is negative square root. Okay? So when you take now the limits of the region, it will become negative 3 to 3. We base it from the variable of integration, and that is y term, okay, or y term. So that is negative square root 3 to square root 3. Then we may now apply the integration process. What is the integral of 3 dy? 3 dy is 3y. What about y cubed? Y squared. Integrating y squared, we have y cubed all over 3. Then from the limits, negative square root of 3 to square root of 3. Okay? So what is that area? So apply now the upper limit first. So we have 3 square root of 3 minus, we have square root of 3 cubed all over 3. Then the lower limit, so minus, we have 3 times negative square root of 3 minus, we have negative square root of 3 cubed all over. Okay? Then simplify now. We have this as 3 square root of 3 minus, we have this as 3 square root of 3 over 3. Then we have here minus negative 3 square root of 3, then this is then plus 3 square root of 3 over 3. So simplifying further, we have now, so combine similar terms, 3 square root of 3 minus negative 3 square root of 3 will give us positive 6 square root of 3. What about this will be cancelled? Okay, this also will cancel. So what is the negative square root of 3 minus square root of 3? That will give you negative 2 square root of 3. Okay? And what is 6 square root of 3 minus 2 square root of 3? That will give you 4 square root of 3. So this is then the area of the unit square units. having the same problem, and then we'll make use of the vertical strip. Can we make use of the vertical strip? So let us draw the figure first. So by vertical strip. Okay, so let us sketch again the region. So we have this as the region now. It is bounded by the line x equals t and the given curve that is x equals y squared. So if we will make use of vertical strip, this is the vertical strip, one representative vertical strip. So we cannot use the vertical strip here because the endpoints of the rectangle are lying on the same curve. And if we're going to define the area using vertical strip, using this vertical strip, the area is 0. Okay, but we have an option. We can still use the vertical strip, but what we're going to do is to use only half of the region, then we will multiply it by 2. Okay, so let us have that now. So we have the area is equal to twice of the areas. If I have this as A1 and A2, so the total area will be twice of A1. Or you can also use the other region that is A2, A1. Okay? So A total equals twice A2. Follow? So if you're going to make use of the first one, A total equals to area 1. So let us now find area 1. So area 1 will be the integral of, okay, so we have this strip here. Identify now the endpoints of your rectangle. So this is a point on the parabola which is now x, y. And then the other endpoint lying on the x-axis, and that is, we have coordinates x, 0. Okay? So we're going to define now the length. The length is the variable of integration, which is dx. Okay? As you can see, we have the strip perpendicular to the x-axis, so this is dx. What about the width? The width will be the formula, which is distance between 2 points, y up minus y down. Okay? So let us now substitute here. We have the length is dx. What about the width? It is y up minus y down. So y up here is y, then y down is 0. Okay? So we have now the integral of y dx. And what is limit? The limit will be from 0 to 3. Okay? As you can see, we have the points. The vertex is at 0, 0. Then we have this point on the line x equals 3 as 3, 0. So the limit should be based on the variable of integration, that is x coordinates. Okay? Because this is variable of integration dx. So we get it from the x coordinates. So that is from 0 to 3. Then we will multiply it now by 2. Okay? So let us now check if we have, let us now integrate and determine if we have the same answer as with regards to the answer in our horizontal strip. So, what is your y here? Your y will take now, since our equation is x equals y squared, we will take now y to be square root of x. So actually there are two roots here, one positive and one negative. But we will take the positive square root because the graph is above the x-axis. Okay? So if we will consider the other side, we will take the negative square root or the negative root. Okay? So what is then your y? Y is square root of x dx. Okay? Then let us now integrate square root of x dx. So integrating the square root of x, we have now 2 times x raised to 1 up plus 1, 3 halves. Then the 3 halves will be 2/3. And that is from 0 to 3. Okay? So what is that? 2 times 2/3 here with us? 4/3. Then replace now x by 3 and 0. So we get square root of 3 raised to 3. The other one will be square root of 0 raised to 3. Okay? So that is what we have for x raised to 3 half. Okay? For the limits of integration 0 to 3. And then evaluating further, we have now 4 all over 3. Then you have simplify square root of 3 raised to 3. That will give you 3 square root of 3. So we will now cancel common factors in the numerator and denominator. So what we get now is 4 square root of 3. And this is now the area of this region. The full region now. Okay? Total area. And the unit is in square units. Okay?